Okay, let us do a review. So first, we need to know what are the domain values for the following inverse functions. Well, sine inverse, what are you allowed to put in or undo? Only everything from -1 to 1. That's the same for cosine. For tangent, you can undo anything from -infinity to infinity. What is the range, or what do you get out? That's when we think about those restrictions. So for sine, it's over here. For cosine, it's on top. And then for tangent, it's also over here on the right. So for sine, it's from -pi/2 to pi/2 is what you will get out. For cosine inverse, you're going to get angles from 0 to pi. And for tan inverse, you're going to get -pi/2 to pi/2 out of that function. Let's use the properties of inverse functions to find the exact value. Well, if I have cosine inverse of a number, I know that's going to be an angle. So I'm looking for the cosine of theta that gives me -1/2. Well, I know that cosine inverse is restricted to the top. And if you remember that cosine is x, I'm looking for where x is equal to -1/2. So I'm looking for that angle. But then on my trig hand, 1, 2, 3, 4, 5, if I want cosine, it's on top. And if I want 1 over the square root of 2, then I must have put down this finger. Right? So my reference angle over here in the first quadrant that will give me an x equal to a +1/2 is going to be a theta reference of pi/3. So that means over here I need to stop short pi/3, so that means I need to open up a total of theta is equal to 2 pi/3. And that is your answer. Arc sine, again, is going to give us an angle. I'm looking for where does the sine of theta equal -3/2. I know that for sine inverse, I restrict myself to the right-hand side of the unit circle. I'm looking for where y is negative. So where is y -3/2? Well, that's going to happen. It's going to be related to where you have a reference angle where you get a positive y is equal to the square root of 3/2. So my trig hand, 1, 2, 3, 4, 5. I know that cosine is on top, sine is on bottom. If I want the square root of 3 fingers over 2, I must put down this finger. And so that finger is pi/3. So that means pi/3 is my reference angle. And if I want something in the restricted area between -pi/2 and pi/2, then that means I must have opened down to theta equals -pi/3. And that's going to be your answer right here. Right? Arc sine of the square root of 3/2, that means that the sine of theta is the square root of 3/2. So if I'm doing sine inverse, then I restrict myself to the right-hand side, and I'm wanting to know where do you get a y equal to the square root of 3/2. So it's going to be some angle in the first quadrant, 1, 2, 3, 4, 5. There's my trig hand with cosine and sine. If I want the square root of 3 fingers over 2, I must have put down this finger, which is pi/3. So that means theta equals pi/3 is the angle I'm looking for. Arc sine of arc sine of 0.7, well, arc sine is just undoing this number. So I want to do arc sine, and I'm doing arc sine of 0.7. So I want to know, that's going to give me just, that's saying when do you have a, well, here's the easiest way to think about it. This is saying that the sine of some mystery angle is equal to 0.7. And then here in a second, I'm going to take the sine of that angle. So whatever angle I get in here, I'm going to take the sine of that angle to get me a number at the end. So if y is equal to 0.7, then I need to find that angle. And it's this, right? So whatever that is, keep it in your head. So that is the angle that when you open up, you get a sine of 0.7. So then I take the sine of that angle and I get back, yes, you guessed it, 0.7. It undoes each other nicely. So then I do cosine inverse of -0.3 and then take the cosine of it. Well, if if I look at cosine inverse, it's restricted to the top. So this is saying that the cosine of some mystery angle is negative 0.3. That means I'm over here with an x equal to negative 0.3. It must have been this angle that I opened up right here, this angle theta. So then I'm going to take the cosine of that mystery angle theta. So I did all this work to find theta. Now I take the cosine of theta, and what is my cosine? Well, it's negative 0.3 because they undo each other nicely. So as long as you stay in the restricted area, cosine and sine and their inverses will all undo each other nicely. So now here we're going to go outside of the restricted area. So let's think about this as a two-step process. First, I'm going to find the sine of 3 pi, and then I'm going to take the arc sine of whatever that number is. Okay? So let's do that now. So first, if I go around this far, that's pi. This is going to be 2 pi. And if I go around again, I'm going to be at 3 pi. So 3 pi is right here, right? So the sine of the y-coordinate right there is 0. So really, I'm trying to find the arc sine of 0. So now, forget about this, and now we're doing a new problem, the arc sine of 0. So that picture down here for sine inverse restricts itself to the right-hand side. Now we'll know, when do you get out 0? What angle between 0 and pi over 2 and 0 and negative pi over 2 gives you an output or height of 0, sine of 0? Well, where do you get sine equal to 0? Well, that would be for 0 degrees or 0 radians right here. Number 7, tan inverse of tangent of 11 pi over 6. So the first thing we do is we take the tangent of 11 pi over 6. So we know if we go around the circle, we're going to get to here, and that's going to be 6 pi over 6. If I go all the way around back to here, that's going to be 12 pi's over 6, right? So I want to back up short here to this angle, 11 pi over 6. So if I go all the way around and stop here, that's 11 pi over 6. That is my theta, got it? So when you take that theta, 11 pi over 6, you get some tangent. Do you have it in your head, yes? So now what we do is we take the tangent inverse, and notice when we look here at the unit circle, tangent inverse restricts itself to over here. And 11 pi over 6, if we're talking about angles from 0 to pi over 2, or 0 to negative pi over 2, then my angle 11 pi over 6 is the same thing as if we had stopped short pi over 6 of our axis. So that means if we go down to here, that's really negative 1 pi over 6. So negative 1 pi over 6 is exactly the same as this. They're going to have the same tangent, but this is something that lives in my restricted area. So when I do tan inverse of that number, I'm going to end up getting back negative pi over 6. So I don't know what this number is, but I do know when you take the tangent inverse of it, you're going to get negative pi over 6. Yes?
He's here to take a makeup test.
Okay, come on in.